All right, we're recording. Can everybody get to 6.4? And away we go. So, oh wait, this is actually not the version of the book I want. Textbook complete, that's the version I want. There we go. 6.2, oh hang on, I gotta scroll past 6.2. There we go, 6.4. We okay over there? Okay. Keep in mind people at home can hear this saga of yours going on. Okay, we are recording. So, the slope-intercept form, we've been playing with this quite a bit because this is the one form of the line that they expect you know how to do in grade 9. This is the one that's in the 9 curriculum. So, this is the one where you should know that it's y is equal to mx plus b. That's a b, I handwrite my b's. Where b stands for the y-intercept, m stands for the slope. So if I give you a fairly straightforward question like example 1, the graph of a linear function has a slope of 3/5 and a y-intercept of -4, write the equation. So I use this form of the formula and I replace the number m with 3/5, and I replace plus b with plus -4. Then I might just tidy that up. I don't like seeing plus negatives. That's the same thing mathematically as just saying minus. And that's it. Don't change it. Don't change the fraction to a decimal. Don't rearrange it. If it wants it in slope-intercept form, it has to be in this order. Okay, and on the first example here, the y-intercept was negative. The second example, the slope's negative. So y is equal to -7/3 x plus 5. You'll notice I did do kind of one little subtle shift here. It's really almost hard to notice, but I almost never put negatives in front of a fraction unless I'm subtracting it, right? Unless I'm doing something, don't write this down, like 2 minus 1/2. If the 1/2 is a coefficient or it's leading my equation, I tend to stick the negative on the numerator. Does it matter? No. -1/2, -1/2, and 1 over -2 are all the same number, right? They're all -0.5 if you divide them. But think about how you actually work with fractions. Once you get them into common denominators, if you're adding or subtracting, the denominator doesn't change. So assigning the negative to the bottom of the number is kind of a useless place to put it. So I tend to always write my negative kind of above the vinculum, which is what you actually call this line here. There, you learned something today. That's called a vinculum. Now, to graph, there you go, math trivia. To graph a linear function in slope-intercept form, what you, of course, do is you plot the y-intercept and count the slope. Yes, this is the same way I wrote it in the last lesson. So, and what do I mean by count the slope? Don't forget that the slope is really rise divided by run. And that's another reason why we don't usually go to decimals, unless the question, is a real world problem where the slope happens to be a money value or something. Unless the question starts with decimals, don't go to decimals because fractions are more useful numbers. All right? How about I'll do example 3, you do example 4. So we've done this before. This is another reason why the 6.4 lesson here can go kind of quickly. When we were reviewing the grade 9 stuff, we did this stuff. So step 1, plot the y-intercept of 2. Okay, step 2, think of this number as -3. I'll just do it over here. -3 for a rise and 4 for a run. So that means go down 3 units, 1, 2, 3, and over 1, 2, 3, 4 units. And then try your best to draw a straight line. Now, ugh, I missed. Make a bigger dot. There we go. -3 over 4, yeah. Down 3. 1, 2, 3. And positively over 4. Right? Down 3 over 4. All right, you watch me do that one. You try the other one. I'll give you a minute. Third page here. Okay, was that enough time? -4 is my y-intercept. I rise 5 and run 2, which puts me there, right? So I go up 5 units and over 2 units. And now I have this line. Oh, don't like that either. Oh, that one's not bad. There.
Draw with your shoulder.
Draw with my shoulder. That's right. You know what? You're right. This is why they failed me in grade 10 typing. I write and type with my wrist down. I should hold it up. You're right. Okay, I'll take that advice. All right, example 3. Done. Example 4. Can you go backwards? If I give you the line, can you make the equation? So basically we read it. I see the y-intercept here is -4. And now I'll count the slope between 2 dots. I rise -2. That's a 2. And I run 3. So my slope is -2/3. So y is equal to -2/3 x minus 4. All right, your turn. See if you can do the B one. Okay, was that enough time? No? Okay, I'll give you another second. All right, so let's see. The y-intercept here looks to me to be -3, so that's my B number. My M number, let's see, I should have given you, I'll put a dot there. So I rise 1, 2, 3, 4, and I run 2. So that's 4 over 2, which simplifies, of course, to just 2. And again, I don't need the over 1 part. So my equation is going to be y equals 2x minus 3. And there we go. There's the two kind of basic skills. If I give you a y equals mx plus b, can you make me a graph? If I give you a graph, can you find me y equals mx plus b? Then some of the applications of this stuff are real-world situations where the relationship between two variables is a linear function. Like something like this, where you have a constant rate of being charged something. Manny pays an initial joining fee of $99 plus a monthly fee of $29. So write an equation for total cost, C in dollars, for n months at the gym. C is equal to 29n plus 99. So this, of course, again, is the y-intercept. This, of course, again, is if I had a graph, the slope would be go up 29 and over 1 to get to the next number. And back in grade maybe 7 or 8, depending on when the first time you started algebra was, you also had a different set of words for this number and this number. Remember what they were called? They both began with the letter C. Constant. This one's the constant. And this one is, technically it's the numerical coefficient, but most people just say coefficient. Okay, so now you can kind of apply that same reasoning to slope and y-intercept, constant and coefficient. Suppose Manny went to the gym for 23 months. What's the total cost? So that will replace, that 23 will replace the n number. And this is now the exact same type of thing we did in Chapter 5 in the R8 part of it. And let's see, 29 times 23 plus 99. I haven't the slightest idea what 29 times 23 is. But I can run it through my calculator. Actually, I already did, and I have $766. Actually, that wouldn't be as hard as I think it is. 30 times 23 would be 690. 690 minus a 23 would be 667. 667 plus 100 is 767, but take away 1 because it was 99, not 100. 766. That wasn't as tough mentally as I thought it was. All right. Oh, there's a C part too. Suppose going to the gym has cost him $505. How many months is that? Now I'm replacing the cost number. So 505 is equal to 29N plus 99. 505 minus 100 is 405, but put 1 back because I was only minusing 99, and that's 406. 406 divided by 29. 29 times 20 would be, what would that be? Yeah, it's actually, no, 290. Is it 14? I don't have an answer for this one. I think it is 14, isn't it? Yep, 290, yep, it's 14. So I'm dividing 406 by 29, and I get 14. And you should probably put a unit on that, months. And that's it. That's really all there is to 6.4. So it's kind of stuff that we've been kind of leading towards in all of our grade 9 review. But having said that, it's a big assignment. So I will give you some work time tomorrow. And then the other thing we'll do tomorrow is once the other group, the guys at home, hi people at home, when they get the chapter 3 review that I handed out, the factoring review, we'll spend a few minutes tomorrow playing with factoring and seeing if you remember how to factor. Okay? And then after that, we'll just let you have some work time. Because this is kind of a big assignment. So going to my, okay, first let me shut off the video here.